Hi everyone, this is a short video on the topic of backpropagation in artificial neural networks. There are four topics that we will converse today. The first is the fundamental concept. Artificial neural networks are computing systems inspired by the biological neural networks that constitute animal brains. They are composed of interconnected nodes or neurons and are used to estimate or approximate functions that depend on a large number of inputs. And backpropagation is a method used in ANN for calculating the gradient of the loss function with respect to the weight in the network. It's a key algorithm in training neural network. There are four key steps in backpropagation, which are forward propagation, cost calculation, backward propagation, and then weight and biases update. For the forward propagation, the input are passed forward to the network in order to generate an output. For cost calculation, the error or cost is calculated by taking the difference between the predicted and the actual output. Backward propagation, the error is passed backward through a network, sorting from the output layer to the hidden layer. Weight and biases update. The weight and biases are updated using the error calculation calculated in the previous step. Essential mathematical formulas. The backpropagation algorithms rely on understanding the derivative of the loss function with respect to the weight, in example the gradient. Here are the essential formulas. First is the cost function. This formula calculates the difference between the network prediction and the actual output. The closer the prediction to the actual output, the lower the cost. The chain rule. This formula is used to calculate how much a small change in the weight affects the overall cost. It's used to update the weight in the network. The weight update rule. This formula is used to update the weight in the network. The weight are then adjusted in the direction that most decrease the cost. The sigmoid function. This function transforms any real value number into a value between 0 and 1. It's used to calculate the output of a neuron. Next, let's come to a simple example. Let's consider a very simple neural network with one input neuron, one hidden layer with one neuron, and an output layer with one neuron also. Hidden and the output neuron both have a bias of 0.2 and 0.3 respectively. Let's go to the first step. First step is forward propagation. First, we need to calculate the hidden neuron output, which first we need to compute the weighted sum of the input. Then we need to apply the activation function, sigmoid in this case. Then we have to calculate the output neuron output. Also compute the weighted sum of the hidden neuron output. After that, we can calculate the errors. The error is the difference between the target output and the actual output. In this case, we have 0.24 minus 0.24. Step 2 is backpropagation. We need to calculate the output neuron derivative, which is minus 0.4. Next, we need to calculate the hidden neuron derivative. After that, we need to update the weight and biases by calculating the delta weight 2, delta weight 1, also the delta B2 and delta B1 for the biases. And after that, we just need to update the new weight and biases. There we go, we have the new weight and biases. This process is then repeated for many epochs or iterations to minimize the error and make the network learn the correct weight. And in real world terms, the neural networks are much larger and more complex. I hope this small video helps everyone who are learning about neural networks If you have any more questions or any further clarification, feel free to ask in the comment section of this YouTube video. Thank you.